Alright, so one of the things that I overlooked, mentioned that as this builds in complexity, that we're going to see some things that will have to go back and be added or corrected. Alright, and one of them was the that jumped out at me was the half 12, which we said early on that we were going to replace with half 13s, the more common thread now. We're making the assumption that it's on the face, and since this is a bottom view, it is going to be coming out to the side that I can see. Based on the angle and the direction, it looks like it's coming off of that tangential face, so I don't really have to create a plane. But if there was any other place where it was going to be located, we would need to create a plane for it. So I am going to run through that as a reference, maybe. So we have a couple of ways to, if we were going to place that hole more on the cylinder, to create a plane to tie it to the cylinder. Well, let's go through the standard. We're going to go with the first things first here. And so I'm going to pick that face, and we will go to the hole wizard, and the hole wizard item will be the threaded hole, tapped, and half 13 with an up to next, and the position. Let's pick on the face, and then go normal 2. This is a good place to use the temporary axes. So temporary axes says anything that's a cylinder is going to show me its center line. And then I can pick and control select and make those coincident. And then the distance up or down, 875 from the top. So I'll go back, control 8, normal 2, we'll pick that A top edge and give it the 0.875. Alright, so that puts it in location. Alright, so that's the one I want to go with. It's on the angle, it's going to the center. It's something that I can indicate from and fairly easily put that item in there. Alright, so now that I've done that, we're going to go back and suppress it so that I can move it out of the mix. And we'll turn the temporary axes off. Another method, if it was on the cylinder, is that we could go with the hole wizard without pre-selecting anything. It's still the tapped hole, and up to next and up to next. And then the position, we can go to a 3D sketch. And 3D sketch is not my favorite, but it is functional. There are times where it can save a little bit of time, but it also creates its own headaches. So if I'm putting this on the cylinder, then it will follow around that that cylinder. And the issue here is I go back and I turn the temporary axes on, and I say make that coincident, over defined. Now what do I do? All right, so I have to have some way to relate that to the 3D sketch and make it somewhat functional. All right, so that's where the challenge comes in with the and probably not my fondest for 3D sketches is that we have that extra challenge of getting this oriented to that cylinder. So if you see 3D sketch, or in the case of let's just draw a line, and you get that red origin that floats around, that means that you're in that 3D sketch, and you probably would at this stage just do better to back out of it and realize that there are some methods, but getting into it a little more complicated than we want to do right now. So I'm going to kick that one out. Another method, let's go ahead and get rid of the temporary axes again. So if I wanted that on this cylinder, I can create a construction line or a center line or a construction sketch, and we'll come out some distance. All right, and the advantage here is that I'm going to be able to control that angle very easily. So 20 degrees, and that gives me a reference that when I select Control Select, or I go ahead into Reference Geometry Plane, and we give it a chance to catch up. My first reference can be the cylinder, and it's going to be tangent 2. And then the second reference is that midpoint. So as I drag that midpoint around, now I can go back to, make sure that that's selected, hit the S key, go into the hole wizard. Position is on that plane. And I turn the temporary axis off again a little too soon. But now I'm in that same situation that I can, if I can reach it, I can tie that that plane coincident to the center line and still get to that point. Now the cosmetic thread gets a little bit weird, which is understandable since we're on the kind of that weird side of the cylinder, but it's functional. Okay, so what's the other? Oh, then changing it, we go back to sketch 38, and I say I want that to go to 30 degrees and rebuild. Then I have control as it rotates around that axis. Right, as long as that plane is able to follow the cylinder around, anytime I make an update, I'm going to be able to, until it disappears. All right, so what's happening now is the plane has gone into the background, so my sketch plane is actually behind the surface, and the hole is still there. I can see it. I can see the cosmetic threads, but because of the order that we're creating it in, it's back behind our usable geometry. All right, so let's do a quick undo, and we'll get rid of those. Guess it's time for another folder. So with the shrunk, let's see, these will be all of the hole locations. And then we really didn't need those two, so I can delete them. All right. And we'll hide the temporary axes. Expand that one out because I got ahead of myself, and right click and then suppress. Maybe? Oh, that was normal too. Let's try the unsuppress this time. Alright, so that gets us our geometry in. Unless I find anything else major, that pretty much completes the body. And then we'll save. Alright, the next one was on the locator. In the process, we found the 30 degrees. So we'll go ahead and pull that locator because when I didn't readily pick it out from that isometric view, I applied a dimension, and the dimension was probably the cause of several other dimensions being less than. So let's see, that is, we're not in the sketch, so I need to edit the sketch, and we'll make that. I would like to know what it ends up being, but since that looks closer to a 40-degree angle, I'm going to go over to Other, and I'm going to make that dimension driven, so it stays there. Smart dimension will be off the horizontal, and then coming over 30 degrees. So we're at 34, so it was a good guess, but 728. That still didn't really do anything to the arc segment. So we're back to, is it really the midpoint? That's driving that geometry. And how far can it go? All right, so if we're really going to try and drive this into those dimensions, I'm going to take that dimension off of being driven and make it driving, 125. And then dimension says that one side will be 062. And it went over defined, and I accepted it, and so it's not really picking up that that dimension. So other than that being coincident, it goes back to being fully defined, but I can't really bring it to that 062 when the 074 is what comes off of the 60 degrees. So I'm not not fully resolved as to what the 60 degrees and the other dimensions are doing. Let's go zoom up, and so based on that information, the 062 off of center, 125 could be the arc, and then the 60 degrees is reference. Yeah, I'm not really following that one. All right, but the main thing is that the 30 degrees has more significance here than the 23 thousandths or so that I was off on the angle, or off on the arc length. All right. So minor details we really wouldn't find out till we get into the assembly if those are critical. Let's see the next one. We have. I'm not really ready to do the swept cuts, but I think the SolidWorks thread tool has become stable enough that let's say it's not creating as many problems as it was previously. All right, so we'll use this as our test case example. We have the chamfer. We're going to somewhere here identify the cosmetic thread, and would like to, if I follow the breadcrumbs, let's see, that's part of the revolve. So one of the things that I haven't really used or don't use a lot is we picked on the cosmetic thread. It shows it to me up here in the upper left, and then there is the feature that it's attached to, the body it's attached to, and the part that's attached to. So when I highlight the revolve, it highlights it in the feature tree, so when I expand out, there's the cosmetic thread. So if I wanted to be able to go back and forth, I'll hide the cosmetic thread, and then under, I gotta find it, under the hole wizard, advanced hole will allow you to work from both sides. So if I had a counterbore on one side and a countersink on the other side, I could build up a stack up within this part and have various geometries as it goes through the part. The thread function then are nominal thread profiles only. Do not use them for production quality threads. Nominal profiles to meet your requirements. All right, we're okay with that. The edge of the cylinder will be out here. And then it's asking for a start location. Well, that would be the face. And if we need to, we would offset it some other distance if it's not a complete thread. And then the up to selection would be a face. So we'll go a little bit further. And then we need to get into the type. Why am I not seeing a type? Or size. So either didn't pick it up or it's not in the, well, that's the 1 3/4 16 that we had to add from the hole wizard, so I'm not sure where this database is now. Since it came up empty, that tells me that there's another location. So that was kind of a false start, but it's good to know. All right, so I need to find that location and how to add an additional thread form to the thread tool. So what I expect it to do, since we picked the really large cylinder, let's go ahead and reduce the edge. See if it'll take a smaller one. Not cylindrical. Really wants to be to the outside or through one of the thread forms. Let's see if it'll pick something on one of these. Nope. All right. Well, I have to do a little more research on that one because it's worked in other cases so far. Well, that's how you get to it. All right, so we'll go back to show the cosmetic thread. When we do the springs and the threads at the same time, we'll do the example as a sweep, and then we'll come back and revisit the threads. All right, so let's go to the next part. Let's go ahead and knock some of these out. We got the cam. I'm not worried about the springs or the bushings at this point. Those are very straightforward. The clamp in the early shows a little better detail. And if if we can find it. And also in the other, so just 60 degrees to terminating about 3 3/8 deep. So let me fly that out of the way. We'll go into the front plane. And then our dimensions are, I don't really need a rectangular shape. It comes down and goes over, so the sketch will be to the side. Go ahead and make a continuous arc, so the tangent, go back to the start point. You should be getting pretty comfortable with that by now. It's an effective method of creating our geometry. And so we close that off. We'll go into the dimension. The 4.125 is an overall, and I didn't hold down the shift button, so let's go ahead and back up. I'll hold down shift, and when I select the arc, notice that it jumps to that max condition. All right, if there was another side of the arc and I was coming to the back side, I would get the min condition. So 4.125. Radius is 0.625, so that gives us a height of 1.25. And the 0.812, 13/16. And then a dimension 1.5 from the center, so I'll still select the circle just in case, but 1.5 to the from the center of the arc back. The through hole, that comes out to be a reamed, another tight tolerance, 626 to 628. Oh, I jumped out of it. Let's go ahead and take it out to the 1.734. I'm going to go ahead with midplane. I'm not entirely sure that I need it to be midplane, but we'll get it into position for it. We're going to hover over the edge until the center point shows up. And then our maximum material condition for the hole is 0.626. And features, extrude cut, through all. Alright, so the advantage of putting this on the right plane is that if I need to do that inner geometry that as a revolve, we can. I'm going to attempt it. I want to try it as a cut extrude with the outside diameter and putting draft on it. So 1.39 as our diameter. Let's see, did we make it to horizontal? No, we'll go ahead and put in the horizontal from the distance. All right, so here's another place where we can use that temporary axis. Since the, well, we could pick the edge, but I think I like the temporary axis better. Is from the hole location back to the center is 2.5. And then when we go to cut this, we're going to extrude cut. We're given 0.375 as the depth. And then we have to figure out the draft angle, 60 degree included angle. And drafting outward, no. Drafting inward, we'll see what it looks like. All right, so kind of missed that one, so that tells me that it's more of a the sidewall, 30 degree. And that looks okay. So we can do it with the circle as long as you want to deal with draft. Alright, so looking at it again, 375 to depth. The draft gets turned on, and we're telling it that the sidewall is tapering in 30 degrees. We're given a 60 degree included angle, but the draft is asking for the half angle or the wall angle. Right, and then if we tell it to draft outward, it reverses and sends it larger instead of smaller. All right, so method 2, whichever one you prefer, I'm going to go ahead and suppress that one out. And we want to be looking at that from the front. I'll go back into the front plane. As soon as we know we're doing a revolve or a cut revolve, infinite length To center line, no, I don't want the midpoint, or at least I don't know that I want the midpoint. We have a dimension, 2.5. And then this is one of those cases where I'm just going to draw the rectangle. We'll place a dimension. All right, the 375. And the rectangle has one side left that's set to vertical. So that vertical gets taken off. And the features, let's see, we had 1.39 for the diameter, so I can select that midpoint, endpoint, sorry. And it got the overall. So let's go from the center line out to the point, 1.39. And then the angle going this way at 60 degrees. Features, revolve cut, and 360 degrees, and there's our angle. So if you can recognize it as the revolve and get the geometry in, revolve has some advantages. Draft may be a little easier, but I don't know that it's doing any better. So 957, let's go ahead and suppress that one. Oh, I did normal 2 again, suppress. And then we'll unsuppress the other one and see if they come out the same. 957. Similar geometries. All right, so the other question is then, since we're given 60 degrees on the included, and no, did I do that right? So I'm going to switch back, and this would be a good place for the configuration so that I can do my what-if scenario without switching back and forth. So if we, let's just mirror that one over, because I don't think that I can do the smart dimension kicks it over to the other side. So if I wanted to see this in relation and go to the mirror entities, I can't have it act as an object line, but I can leave it as a center line and verify as a driven dimension that I have it set to the 60 degree. All right. So if the geometry doesn't make sense visually, then we'll go back and we'll make some adjustments. All right, the 2 radiuses on the inside then, the fillets, we'll put those in last, 0.125. And accept. Alright, I think that was it. So we can save that one. That was item 5, the clamp. And we'll go ahead and close that one back. Okay, the item 3 clamp then, geometry is not overly complicated, a couple of cutouts. All right, we'll probably end up referring back to the early as well, but from the center lines over back, we're going to try to identify the overalls. So this kind of lends itself to the contours and regions. I don't know that I need to do a layout sketch as far as its complexity, but we can do some contour and region and maybe share some sketches to get this geometry in place. So let's go ahead and start with its overall. So new, part inch, and no real preference, so we'll open up the sketch. I'll take it this way to be different. And so from the very top to the very tangent on the bottom is 2.5. We're not really given an overall. So if they're chain dimensions, well, we're kind of moving towards a layout if we're going to have to figure out these chain dimensions. So, oh, there it is, 9.125 to the center line of the hole. All right, I really don't have a problem with for that envelope selecting the chain and just sending all of those over to for construction. and saying, all right, your construction lines, you're not participating as object lines, but I have enough of an envelope to get it started. Let's see, height-wise, we have another line at 1.5. So I guess I've decided that I'm going ahead with the layout, or it's decided for me that there is enough complexity in here to deal with. All right, and then we're going to have another line that is 1 inch back. And then let's see, that end geometry is going to come off tangent, but then up and over. So let's go ahead and resolve that one as a tangent arc. And I'll just bring it back to locate. And we'll make sure that that goes coincident. We have a radius of 0.625. And so that gives me a location. Let's see, there is a back relief. It almost looked like it was in blue. No. Okay, so there's a back relief, and that's another interesting way of dimensioning, but let's get it in there. So 60 degrees off the horizontal. And then from the center of the arc back, 0.75. And the functional gauging on that one's a little, got to be a little weird, but I guess it's just a relief and 2 decimal places, so that one's pretty wide open. Let's see, we have a radius. I'm going to fly this back in. Alright, so trying to decipher 225 up and then a radius of 3.093. Alright, so that can just be a circle. And we'll pick up the arc wherever it falls out at. Alright, so to the center of that circle is 3.875. And then, interesting, they go to the circle, but then they go from the top out the 2.25. All right, we said we had a radius, so I'm pretty much just going to accept that. Go into the liters. I'll switch it over to radius. Double click. 3.093, and then I don't have to do the math. Otherwise, I would do 3.093 times 2 and get 6. Well, here I go doing math in my head. 186, 187. All right, depends on where the rounding comes in. All right, so I don't want to see the shading contours for my layout, so I added that button so we could turn it off conveniently. So that's what I'm going to do. Let's see, the very top was this segment, so I'll just create the line off that way. And one line comes down and gets a 1 inch off of the end. And so that one didn't quite pick up, or it didn't pick up everything. Oh, it picked up the connection. So that'll go horizontal. And if I were to connect, well, actually, yep. Okay, got a little button happy on that one. Alright, and then radius of 0.25 going into a radius of 0.5. Another one of those interesting, yeah, that's what it says, 0.25, and then it picks up and goes to a radius of 0.5. And 30 degrees, oh, picking it up off of the line. So yeah, I'll go ahead and put that segment in. We can come back with a tangent arc. Oh, I didn't carry that one far enough, so Control Z, Control Z. Right, undo to the point I can get back to that arc. And then we'll bring another tangent arc off. Alright, so 0.25. We'll let that one shrink. It's automatically tangent to the start, and so we'll make it tangent to the bottom and overall. 0.5. Alright, so nothing's moving or behaving badly. Come off with another line, and then see if we can get that 30 degrees in. Showing that off of vertical, so the adjacent angle would be 60. I can stay with the 60. And that goes fully defined. Alright, so the question is, do we start trimming? Do we leave it? Do we start picking regions? Let's see. Let's go ahead and put in one more piece of geometry, that notch out, and then the angle. Alright, so the dimension for this one is 5 degrees off the base, so here's one of those places where I would use the arrows and go 5 degrees, and 1.312 on the length. And then its distance off of the end is 2.65. Oh, 625. Oops. Alright, so at that point it looks complicated enough. It feels like a layout sketch. It looks like a layout sketch. It's a layout sketch. Alright, so we'll go layout. I'll open up a sketch on the front plane, and the advantage of the layout sketch then is that I can pick this geometry, and we'll go to convert entities. If that one cooperates, again, the convert entities are on edge entities, and the endpoints will be shown in black until you move them. And so don't move anything that you don't want to have update or move. Alright, so if we go from there to there to there and convert, then this one I will trim. So trim to closest, that can go away, and that can go away. And actually, that can go away. And we'll go back to select, and that gives me my geometry. Features, extrude boss base, we're going to go mid-plane, and the distance, as soon as I find it, 2.25, mid-plane, 2.25. Alright, so that gets us started. On the front plane again, we'll pick up another convert. I'm pretty well satisfied that it'll stay across the bottom. My line geometry will at the very least need to stay tangent to the arc to fully remove that geometry. So tangent and tangent. Alright, so interior to the part, and then its distance is 1.03. See if we have a better picture of that in the yeah, 1 and 1/32, so 1.031. Features, extrude cut, mid-plane, 1.031. Get that back in here. 1 inch on the end, ½ inch shows that it's on center. 2.25, 1.125 also on center, and then the hole is on center as well. All right, so same thing on this end to make that clamping structure. Front plane sketch. Let's just go with a rectangle this time. And we'll bring this out to our layout sketch. Bring that up to a point. Everything else is there. Features, extrude cut, 1 inch. And it's going to be a mid-plane condition. Alright, so looking pretty good. Open up the sketch on the outside. Convert the entities. I won't worry about converting the top and the bottom. We'll just sketch those in. And then the depth. Didn't go far enough. We're into that geometry, and it does look a little foreshortened. So let's see, did I draw that one last? Nope. Alright, so let's put the one back in. And then again, because I did convert entities, I can pull that up and pull that one up. And we'll go back to Control 1. And my cutting tool then just intersects the rest of the part. And that looks really weird. I don't know why it's optical. No. Nope, it stayed on edge. Angle of 90 degrees, so it's just the circle and the 5-degree angle that makes that one twist a little bit. Depth is then 0.531. And we have the cutout. So that's one that doesn't quite show up in the isometric view tilted back as much as it is. All right, and then the through hole, 500 to 502. Maximum material condition then is 500. Let's go ahead and hide the layout sketch. Set the dimension. Go horizontal. And then its location from the center lines. Alright, so again, going to the view, activating the center line. And we'll pick from that location back 5.5. And that one's going to be an extrude cut through. And then I guess it would help the last ones, 624 and 625. Alright, so a little bit of interference there with all the pop-ups. Maximum material condition, 0.624. Features, extrude cut, and we're going to go through all. Alright, so that should be everything except for the radii. So 125, 125. So we'll pick an edge. Pick the edges. Let's see, another edge up here. That one's 0.375. Oh, I didn't catch that one. The hole depth is actually 0.875. It doesn't go through, so that means it's going to pick up a spring. Okay, we'll go ahead into the fillets. 0.125. And I could go back into the sketch and add the actually, it looks like there is one in that corner. It doesn't call it out specifically, but assumption would be that it's probably there. And then fill it over the outside, 0.375. So I could go back into the sketch for that one and modify the sketch if needed. Don't see anything radius on the interior. But we do need to go back to the cut extrude. Edit the feature, and instead of through all, it's a blind in condition, 0.875. Alright, because it's 1 inch, that's going to leave us, maybe not that one, let's go to that one, it's going to leave us 1/8 of an inch for the spring to retain. Alright. I think that's looking like it's in pretty good shape. Let's go ahead and save as item 03, the clamp. And then we'll come over to the rough locator. Kind of jumps out as a revolve. We have the countersink, so we'll be using our design library countersink for the grind. What's not clear is what's going on with the 45.25 off of the center. So the early gives a better detail, or slightly better detail, where you can kind of see the 10 degree, where the 10 degrees is coming in off of, rather than the cutout section. And then over to the geometry. So on this one, looking at the profile, and again with that 7 degree, I'm inclined to believe that whatever's locating, until we get in the assembly, I don't know for sure, but whatever's locating, I'm going to bring that off perpendicular, but in the sketch I'm going to leave myself the ability to get back into that geometry. Alright, so 1/4 of the profile up and over, the relief, back in, and we'll sketch that as a revolve and then remove the end geometry. New part inch, front plane, open up our sketch. Because we're doing the revolve, center line, infinite length, horizontal. Place it on the origin. We'll come up, over, back. I'm going to go ahead and include the neck. And so either the 1/32 radius or the 063 by 031 deep. Whichever way you'd like to go about that. Back over. Might as well include the chamfer. And then close it off. If I don't close it off, SOLIDWORKS is going to ask me if I'll let it close it off. Alright, so I might as well put it in. 2.375. We'll auto scale. Let's see, the outside was 10 degrees, so the end point and the line, nope, I got the midpoint, did not want that. We'll pick the arrow, go 10 degrees. Let's see, a height of, have a radius of 0.937, so 15/16. And a height of 0.25, and then the width 0.374 to 375, maximum material condition 375, 0.063 and 031 deep, and we'll go ahead and set the 45. See, the call out was 063 for a width on the chamfer. And then the diameter 999 to 9985. We'll go with the 999. Alright, overall length 2.625. Alright, so that gets me enough geometry to start with. That design library sketch, if I'd kept it, I probably could have brought in the revolve and just put in that segment, included the countersinks or the center drills. I still like the one we ended up with a little bit better. All right, so the majority of the geometry is in place. I'll open up the sketch. Probably going to need a construction line to reference this to. So center line, construction line through the midpoint, through the center of the circle, and 45 degrees with a 0.25 off of the center. Okay, so because this is an open contour, we'll try it, but I suspect that I'll have to either convert the edge or draw in the arc. If I go extrude cut, then I have the blind in condition. I could put in the 0.25, and then the direction of the cut is correct. I would get a result, but it's looks like it's interfering. So let's go. Oh, because of the 10 degree, I'd actually, let's go Control 8. Instead of terminating at this point, it's not projecting beyond where I've made the sketch. So let's go ahead and pull out to the bottom of the draft, or bottom of the angle, and see if that'll work. 0.25, accept. Okay, it didn't tell me no that time, but it didn't. Oh, there it is. Alright, so that being the case, we can still utilize what's there. And I'm going to convert the entities. So back into the sketch, convert entities, brings that sketch in. It spans long enough to be able to cut that back. Could have gone all the way to the outside. It really shouldn't have mattered. Extrude cut. Well, interesting that we have to do the region for the center line, but yeah, I get it. Up to surface. And it didn't go all the way through. That's interesting. So I wonder what's up with that angle that it didn't calculate it out. Alright, so that being the case, that may be why the other one didn't play well. So, backing up, we're going to get rid of the converted circle, convert the outside entity. We'll get rid of the coincident, bring it up coincident, and reapply it. Get rid of the coincident to the inner, bring it up, reapply it. And then we already have the cut extrude, so let's see if that makes the cut. That's actually a pretty interesting shape then. So let's clear out the regions. Oh, there is another contour there. Alright, so here's a place where the contours, it didn't quite pick it up. So that turns out to be the issue. We remove all of that. Then it makes the cut. Or, in the sketch, this is a place where we can go ahead and trim off the excess. And out of the feature definition, we'll clear the selections and let it just be a normal cut without the contour region. Okay, so that gives me the majority of still the 7 degree relief. So on the front plane, we'll put in the triangle, and 3/32 on the depth. So 0.93, and then a 7 degree angle. Alright, and then it is 9/16 back from the face, so 0.562. And the issue here is still the manufacturer. I guess the one that I would be most interested in is if I come off perpendicular, do I have enough clearance to bring that end mill in? All right, so there's perpendicularity. It does. And then we close off the end. And the choice then is to stay with the contour and region or convert to construction geometry. If it's construction geometry, then this is the relief. And what I'm looking at is if I set this up at the angle, I can just run an end mill. Let's see where it'll turn. I can run an end mill across that face, and that little bit of extra, if it's not contacting or providing something as a location, I'm not real worried about it. It just improves the manufacturability. Otherwise, this becomes a little bit more of an angle cutter and a little more complicated to make that edge vertical. And if it needs to be, we'll find out later, but I have the mechanism to go back and correct it by just converting those entities. Alright, so any radiuses? Okay, I do not see any radiuses, and then that leaves our design library geometry for the center drill. Located on the face, we'll stay with the number 3. It's asking for an edge. And so that one goes into location. And same thing, we'll place it on the face. It's asking for an edge. See if it, we need to pick. And now it's asking for an edge. Pick the center. And we have the center drills in there for the grinding between centers. So this was the item 15, rough locator. Alright. So there's nothing really clocking this that says it has to be at 45 degrees. If we were at 0.25, let's go back to this. If we were at 0.25 and we went straight across, it would have the same net effect. Maybe there is a clocking. Wherever it locates on our relief. So that being the case, alright, we'll have to see where that ends up being placed so that we can come back to that location. Alright, so that would be the only concern is if that's going to be in position and then whatever the 45 degrees is in relation to that item. Alright, so let's mark a few of these done. And again, I'm not too worried about the bushings. Those are pretty straightforward. Let's do a minus. We'll go back to manipulate. Alright, we got those. It's looking pretty good that we've got most of the parts. And that leaves 20, the block, the 21, the slides, left and right slides. And so that subassembly is the one that I want to do as the top down. All right, so one more quick pass, making sure I didn't miss anything. All right, I'm going to go ahead and stop the video here and make the top down a separate deal.